Let's continue with chapter 3. Problem example 3-22. And in here, they are asking us to determine whether the resistor in each of the circuits has been damaged by overheating. So what we need to do is calculate the power rating of the resistor so that we can see if the value given it is adequate for the power that it is dissipating. So in here we have 9 volts and we have 100 ohms. So we use the formula where we need the voltage and the resistor, and we calculate that the power dissipated by that specific resistor is 0.81. So the resistor can handle 0.25 or 1/4. So this resistor is damaged. It has been overheated. For B, the same way, they're giving us a voltage and a value for the resistor, and also what it is the power rating of that resistor. So we calculate the power rating based on the resistor and the voltage, and we get 0.38. So the resistor can handle up to 0.5, excuse me. So this resistor is working properly. Then we have 5 volts, 10 ohms, power rating 1 watt. If we calculate it, we get that this resistor is actually dissipating 2.5 watts. So the resistor, it is damaged. In problem 3.3-24, they're asking a certain electronic power supply requires 25 watts of input power. It can produce an output power of 20 watts. What is the efficiency and what is the power loss? So we have the P in is 25 watts. We have the P out to be 20 watts. We define efficiency as P out over P in times 100 to make it into a percentage. So every time we calculate efficiency, it's going to be output over input. It doesn't matter if it's power, voltage, anything. We always do out over in. And if we want to make it into a percentage, we'll multiply it by 100. So in this case, this power supply is 80% efficient. The way we define power loss, it is the difference between power in and power out. So the power loss is the difference between the two power measures. 25 as being the in and 20 as being the out. So we have a power loss of 5 volts. Then they go ahead and ask, a power supply has an efficiency of 90%. Actually, it says 95%. If the P in is 50 watts, what is the P out? So based on the definition of efficiency, we solve for the P out, and the P out is going to be 47.5% watts, which makes sense. It should be very close to 50, right? Because we are at a 95% efficiency. Let's do example 3-25. How many hours? So right here they're asking for the battery life, of the life of a battery. For how many hours can a battery deliver 2 amps if it is rated at a 7 ampere hour? So 7 ampere hour, and the current that it requires to supply is 2 amps. So the number of hours of the life expectancy of this battery is going to be 70 ampere hour divided by the current. So we get that this battery or power supply can constantly deliver 2 amps to whatever the load is for 35 hours. A related problem here, it says a certain battery delivers 10 amps for 6 hours. What is the minimum ampere hour rating? So the ampere hour rating, as the name indicates, you just multiply the current by the time that is run, and then we get its ampere hour rating, which in this case is 60. And that's it. With this, we finish chapter 3.